Hello everyone, welcome to Mr. Academia YouTube channel. Remember to subscribe, share, like and comment on all our lessons. So we are going to look at work, energy and power, and specifically we are going to look at work as a topic. So we define work as the energy transfer that takes place when a force causes an object to move. So meaning that for work to be done, a force must move an object through a distance, meaning that we involve force and distance. So work done can be calculated by taking the product of force and distance moved. So that's why we have work equals force multiplied by distance is. So if you look at the formula there, we know that work done, of course, it is measured in joules since force is in newtons and the distance is in meters. So basically, when we are calculating for work done, the force must be in newtons and the distance must also be in meters. We look at an example here. A box is pushed across a floor by a constant force of 100 newtons. What is the work done by the force to move the box 5 meters? So the distance is 5 meters and the force is 100 newtons. So this is the box being pushed horizontally by this force of 100 newtons. So the work done is force times distance. Since the box is being pushed horizontally, so the force is 100 and then the distance is 5 and the answer is 500 joules since work is measured in joules. So if the flow is smooth, so it means that all the energy is used to accelerate the body, meaning that the energy is changed into kinetic energy, which accelerates the body. But now what if there is an opposing force? That is, if the flow is rough, of course, if the flow is rough, there is some kinetic energy. So some of the energy is lost in form of sound and heat because of that opposing force due to the fact that the flow is rough. If you look at an example whereby the force is acting at an angle, like in this case, the same box is dragged by a rope, which is raised at an angle theta to the horizontal. So you can see that this force here is acting at a certain angle to the horizontal. So in this case, what happens, or this time, the box moves in different directions because this force is at an angle. So the force here can be resolved into a horizontal component and also a vertical component. So you can see that in this case here, the horizontal component the horizontal component is F multiplied by the cos of the angle, which is F cos theta, and the vertical component is F multiplied by sine of the angle, which is theta. So, but when calculating the work done, the vertical component will not do the work because the box moves in the horizontal direction. So the vertical component, we don't use it to calculate the work done because the box in this case is moving in the horizontal direction. So that's why when calculating the work done by the force at an angle, we take the force in the direction of movement. In this case, the box is moving in the horizontal times the distance covered. So that's why we use F cos theta multiplied by the distance, which is S, which can also be written as Fs times the cos of the angle. So if you look at an example here, of course, this car will be moving horizontally. So meaning that when taking the work done, we consider the horizontal force, which will be 10 newtons multiplied by the cos of 30 degrees times the distance moved, which is 50. So the work done is Fs cos of the angle, which is 10 times 5 meters times the cos of 30 degrees, giving us the answer as 43.3 joules. Thank you for watching. Remember to subscribe to this channel, share, like, and also comment on all our lessons to enjoy the best out of our lessons. Thank you. Hashtag grow, subscribe.